So today we're graphing equations in slope-intercept form. First we're going to look at the general way of seeing the equation. And the slope-intercept form of a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. So m rhymes with slope, and if you're in my class you know what that means. So just in general, the algebraic way of writing it is to have it in the form y equals mx plus b. In this form, when you plug your numbers in, it tells you that 2, in this example, is the slope, and 6 is the y-intercept. And so I would write m is equal to 2 over 1, just so I know what's happening with it. Remembering that we're talking about the change in the y over the change in the x when we talk about slope. And since a whole number is there, we would put it over 1. Also, we need to remember that the y-intercept is not just a number, but is a point on the graph. And that point always corresponds to an x comma y, where the x value is 0, and the y value is the y-intercept. So in this case, my x value would be 6, my y value would be 2. Excuse me, my x value would be 0, my y value would be 6, and the slope would be 2 over 1, or the change in y would be 2, and the change in x would be 1. Graphically, a separate example would look like what's on the right. We have 0 comma b as the point of intersection with the y-intercept, as we can see right here. And then the slope of this line, if we went down a certain amount and to the right a certain amount, we would get a negative slope. And that slope would be m minus m over 1. Okay? And so we have a negative slope, so we're going down, it's slanted downward. And the change in y over the change in x, m would be the change in y over the change in x. A good way to do this when you're looking at a graph is to pick one point that's on the line and then follow it to another point that's on the line. And so we would go down a certain amount and over a certain amount, and these two pieces, the change in y piece and the change in x piece, would give you our slope. So let's look at an example. We're going to write an equation in slope-intercept form for the line with a slope of 3/4 and a y-intercept of -2. So they give us that m in this case is 3 over 4. They give us that b in this case is -2. And since it's y equals mx plus b, I'm going to have y is equal to 3/4 x minus 2, because we're adding a negative. So when we add a negative, it's the same thing as subtracting a positive. Now, recognizing that we don't have an x1 or a y1 here, we have an x and a y, because this is a general equation for every point that will be on the line that I'm about to graph. And so the general way we want to do this is to take the y-intercept as a point and graph that. So that would be -2, 0 comma -2, which is down here. And then we would use the slope as a set of directions to get to the next point. So the change in y is a +3, so that means go up 3, so 1, 2, 3. And I don't put points down until I actually end both sets of directions, so the up and down direction and the left and right direction. So I'm going to go +3 and then 4 to the right, because right is positive for x and this is y. So I'm going to go 1, 2, 3 this way. And then I'm going to go 4 to the right, 1, 2, 3, 4, that way. And this is my new point. So I have a point here and a point there. I could do it one more time. I can go up 3 and 4 to the right. And that would give me the same slope. And if you pay close attention, well, how did I get from point 1 to point 2? Well, I went up 3, and 4 to the right. Well, I could technically go down 3 and 4 to the left. And as you can hopefully see, the steps are really the same. And so if I have m is equal to -3 over -4, or -4, I still end up with a negative divided by a negative is a positive 3/4. And so I have enough points. I really only need 3 of them to make it nice, but I can make more if I want. And then I'm going to erase, because these were just for explaining, I'm going to erase these little steps. And what I'm going to do is draw a line that doesn't just connect the points, but it goes through all of the points. And it goes through all of the points and allows us to have a line that not only goes through all of the points, but goes to all other points on this that follow the same slope, and the same y-intercept. And I'm going to write the name of the equation on the equation, which is y is equal to 3/4 x minus 2. And now I'm completely finished. So first thing I do is I recognize what my slope is and my y-intercept is. Then I use the y-intercept and plot it. Then I use the slope as a set of directions to get to my new point, my next point. I'll do it a couple times, probably 3 times as necessary, 4 times is if you want to. Then I draw my line with arrows on the end to make sure that I know that this line continues on off the paper if I want to let it go forever. And then I write the name of the line, which is the equation, which is the rule that all the points on this line follows. Let's do another one. So in this case, we're not given the line in y equals mx plus b form. We want it to look like this in order to use this form. And so what we're going to do is what I like to say as solve for y equals mx plus b. So we're going to solve for y. We're going to rearrange this literal equation to get it in the form that we want to use. And so, just like I always do, in literal equations, I'm solving for y. So the first thing that's happening to y, it's being multiplied by 5. Then the next thing is you're subtracting 2x. So now I need to go backwards and do the opposite. Well, in order to go backwards and do the opposite, I'm going to first add 2x, and then I'm going to divide by 5 to get y by itself. And so this is the way we solve. We undo the math that's present, and so this is exactly what I'm going to do. So I'm going to have minus 2x plus 5y is equal to 10. I'm going to add 2x to both sides, just as I said I would do before. And so I get 5y is equal to 2x plus 10. (2x plus 10), and I'm going to divide everything on both sides by 5, because that's the only way it's legal. And so I get 1y, or just y, is equal to 2/5 x plus 2. I now have my equation in slope-intercept form. I'm going to write my slope as a fraction. Well, I already have it as a fraction, so that's nice. And I'm going to write my y-intercept as 0, comma b, or 0, comma, positive 2. And I'm going to use that to my advantage and now graph. Remembering that this is the y-axis and this is the x-axis. I'm going to go up 2 from the origin, 0, comma 2. I'm now going to follow my slope to get to my next point. So I'm going to go up 2 and 5 to the right. And then I'm going to do it one more time, up 2 and 5 to the right. And I'm going to do one time in the opposite direction, which is unnecessary, but I'm still going to do it. Okay, I now have all my points. I'm going to draw my line, and I make sure that the line goes through all the points, has arrows on the end to remind me that it goes on forever. And the very last thing I'm going to do is write the equation in slope-intercept form on top of the line so I know what I'm talking about. So it's 2/5 x, 2/5. So it's 2/5 x plus 2. And I've graphed and labeled my equation. Now we're going to look at one where it looks a little bit different. And what we're looking at is the fact that So now we're going to look at an equation where we don't have an x. And so we need to know what this means. And so first we're going to try to get it into y equals mx plus b, remembering what that form looks like. And so what I'm going to do is I'm going to divide both sides by 2, and I should get y is equal to 1/2. Now what this is telling us is that I don't have a part of this equation where the slope changes. And let me rephrase that. I don't have a part of this equation where the x values matter. The x values aren't there. The only thing that matters in this equation, based on what I have, is that y is equal to 1/2. Well, 1/2 is halfway between +1 and -1. Excuse me, +1 and 0. And so this is y equals 1/2 right here. That's my y-intercept. And so really what I'm looking at is y is equal to 0x plus 1/2. Well, if I have a slope of 0, that's basically telling me that my change in y is 0 over my change in x. And so x doesn't matter here. It's saying that I always have no change in y. And so what I'm looking at is, well, over here, y is equal to 1/2, and over here, y is equal to 1/2. And all the way this way, y is equal to 1/2. And down here, y is equal to 1/2. And y is also equal to 1/2 out here because x doesn't matter. That's what we get when we look at this problem. And so if I connect this line, what I see is that I get a horizontal line, and that is because I still write my equation on top of it, y equals 1/2, because it doesn't matter what's happening to x, and the change in y is 0. Y never changes. Y is always 1/2, and therefore I have a horizontal line. Just the same way I could look and see, well, what if I had x equals 4? Well, if I had x equals 4, the same thing applies. Okay? Oops. Okay, if I had x equals 4, the same thing basically applies. X equals to 4, and if I'm trying to graph this, tells me that y doesn't matter. And so that's saying, well, x can equal 4 here, and x can equal 4 here, and x can equal 4 up here, and x can equal 4 down here, and down here, and up here. And so that's saying that, well, all of these points that are on top of each other are x equals to 4. And so when I connect them with arrows on both ends, I get a vertical line where x is always equal to 4 and y doesn't matter. And so these are the two special type of lines where the slopes are different, where the slopes aren't a combination of change in x and change in y. We're called line, and this is a vertical line. And so what I have is the other side to this, right? I have one where the slope is 0, that's my horizontal line in red, and then I have my other one, well, since y can be whatever it is, but x has no change, I end up with 0 on the bottom, and y can be whatever it is. But I can't have 0 in the denominator of a fraction. It's part of our basic math. So what we get is what we call undefined. And so we have a graph with an undefined slope, because it's a vertical line. And that's in blue, and then we have a graph with 0 slope, and that's a horizontal line. That is defined. So please take a look at both of them. They're both important, and they're both a little special because they're not a combination of the two. It's either x doesn't matter for a horizontal line, and you get y equals to a number, or the y-intercept, or x equals to a number, and y doesn't matter, and you get the x-intercept, and you get a vertical line. And I have to make sure that I put arrows on both ends. So in this case, it says, which of the following is an equation in slope-intercept form for the line shown? When tackling a problem like this, it's very important to recognize where your y-intercept is if it's given to you. That helps you figure out most of the problems when you start. So, my y-intercept, based on this graph, is at 0, -1. Well, right then and there, that eliminates 2 of my possible choices. And the 2 possible choices that I now have are 1/4 for my slope, or 4 for my slope. And that's really 4 over 1. So I need to really make sure that I know that the slope is the change in the y over the change in the x. And so I have to see, how do I get from one point to the next? Well, if I start at my y-intercept, I'm going to go to this point over here. Well, to get to that point, I could have gone up 1 and 4 to the right. Or I could have gone 4 to the right and then up 1. Well, 4 to the right, that means that x is 4. Up 1 means, that the change in x is 4. Up 1 means the change in y is 1. So actually, this is my slope, and that gives me the right answer.